Okay, this last section in Chapter 8 is on solving log and exponential equations. So we've done a little bit with this, and we've used the different rules, the quotient rule, product rule, power rule, change of base rule. So we're just going to actually now apply some of these and do some solving with them. So remember, the common base rule for log says that if you have log of base a is equal to of x is equal to log base a of y, then you could drop your logs and then you just have x is equal to y. But in order to do that, you must have the same base. You must have the same log base to do that. So if you think about when we did just exponential, okay, when we were working with exponents, if we had 3 to the power of x plus 1 is equal to 3 to the power of 2x minus 3, my bases are the same. They were both 3, so I could just drop those and say x plus 1 is equal to 2x minus 3, and then just solve. So I would have, bring my 3 over, so I'd have 4 is equal to x. So the same thing works with logs. You must have the same log in order to, or you must have the same log base in order to solve. So if I look at my question here, log base 7 of x is equal to log base 7 of 45 minus log base 9. So first though, before I can do anything, I need to make sure I've got my logs together, if you want to think of it that way. So I would leave this as log base 7 of x is equal to log base 7 of 45 minus log base 7 of 9. Using my quotient rule would be the same as log base 7 of 45 divided by 9. So you have to simplify first before you can solve. So this would be log base 7 of x is equal to log base 7 of 5. So now what that means is I can drop my bases, my log bases, now have x is equal to 5. So the key or the trick to all this is to remember that in order to drop anything, they have to be the same. So let's try these next ones. Log base 7 of x plus log base 7 of 4 equals log base 7 of 12. So same thing, I have to simplify before I can solve it. So if I am adding there, that means that I multiply my values together. So this would be log base 7 of 4 times x equals log base 7 of 12. So now I have a log equals a log, so 4x is equal to 12, so x is equal to 3. So all I did was divide by 4s there if you missed that. Okay, log base 5 of x plus 1 plus log base 5 of x minus 3 is equal to 1. So this is a plus here, so this becomes log base 5 of x plus 1 times x minus 3. And if my answer is a 1, using my log rules from that section, I think that was in section 8.3, log base 5 of 5. So when your base and your value are the same, that gives you an answer of 1. So this is then equal to log base 5 of 5. So what I have then is x plus 1 times x minus 3 is equal to 5. So now I just do solving for this. So in order to solve, I have to multiply this out. So I have x squared plus x minus 3x, so minus 2x minus 3 is equal to 5. So I just FOILed that. X squared minus 2x minus 3 is equal to 5. Bring over my 5. So that means I will have x squared minus 2x minus 8 is equal to 0. So product and sum factoring will give me an x minus 4 times x plus 2 is equal to 0. So x is equal to 4, or x is equal to negative 2. So whenever you are working with these, though, you have to remember that you have to check to see if there are any restrictions or if something doesn't work. So if I check these, okay, so log base 5, I'm going to just switch this down a little further. If I substitute my 4 into my x's, so with the x is equal to 4, I would have log base 5 of 4 plus 1 is 5, plus log base 5 of 4 minus 1, or 4 minus 3 is 1, and that equals 1. Okay, so log base 5 of 5 would work, log base 5 of 1 works. If I try to substitute for the x is equal to negative 2, I'd have log base negative 2 plus 1, base 5, sorry, plus log base 5 of negative 2 minus 3 equals 1. This is a log base 5 of negative 1 plus log base 5 of negative 5 equal to 1. Now, if you remember from our rules that we did in section, I think that was 8.2, you can never find the negative value. Remember, you couldn't have, your base couldn't be 0, 1, or a negative, and the value you're finding couldn't be a negative. So you can't do this because your value can't be negative. So that would mean we throw out this, and that is your solution. So you have to remember when you're solving these, always check restrictions of your log answers. Now, I didn't check on this one because the only thing I was substituting in here would be a 3. So by using the change of base rule, I could solve for that and find my answer. Okay, next example. Looking for errors that were made in this. It says, find the mistake in this example. And then we want to solve it correctly. So I have log base 2 of x plus 4 plus log base 2 of x minus 5 is equal to log base 2 of 7x. So they went x plus 4 plus x minus 5 is equal to 7x. So what they've done is they have dropped the logs already. And that is their mistake. Okay? You can't drop the logs before you simplify. And when they did simplify, they didn't simplify correctly either because they took this plus and left it as a plus. But if you are adding and your logs are the same, that means you should have been multiplying there. So what this should have looked like then is log base 2 of x plus 4 times x minus 5 is equal to log base 2 of 7x. So then now when you have a log is equal to a log, then you can drop the base. So I have x plus 4 times x minus 5 is equal to 7x. So this will be x squared minus x minus 20 is equal to 7x. Bring over your 7x. X squared minus 8x minus 20 equals 0. Product and sum. X minus 10 times x plus 2 is equal to 0. X equals 10. X equals negative 2. So now I can check. X is equal to 10. I would have 14 and a 5 and a 70, so that one works. Negative 2 plus 4 would give me a positive 2, so that's okay, but negative 2 minus 5 would give me a negative 7. Doesn't work, so I have to throw that one out. So that is my solution. So that's how simple it is to check for these. If you end up with a negative value inside one of your things that you're substituting into, then you can't use that value. Okay, next one. Find the mistakes in the example below and then solve it correctly. So 2 times log x is equal to log x squared plus x minus 2. So they went to 2x equals x squared plus x minus 2. So the mistake that they made is they dropped their logs right away, but what they needed to do was, remember, when there's that value in front of the log, it becomes an exponent. This is the power rule. So what this should have looked like is log of x squared is equal to log x squared plus x minus 12. So now you have the same logs happening, so you can drop your logs and start solving. So I have x squared is equal to x squared plus x minus 12. I bring over that x squared, I have 0 is equal to x minus 12, so 12 is equal to x. So if I substitute in here, substitute the 12 into here, that would be 12 squared. That works. This would be 144 plus 12 minus 12. So those would just cancel, so you'd have a 144 in there. So that one works. So that is your solution. Okay, let's try the next one. Okay, so log base 2 of x minus 2 plus log base 2 of x is equal to log base 2 of 3. So these are all base 2 logs. That works okay. But I have this plus sign in here, so I need to simplify first. So this becomes log base 2 of x minus 2 times x is equal to log base 2 of 3. So now that I have this as a log something equals a log something, my bases are the same, then I can drop the logs. What the easiest thing to remember is that you always want to have a log with whatever the base is equals a value equaling log base and a value. You don't want to have a plus sign in between here, so I couldn't have this as x minus 2 plus x right in here because that wouldn't be one log value. I would have to do something to combine those. So now that my logs are the same, I can drop them, so I have x minus 2 times x, so I'm just going to multiply those right now. So x squared minus 2x is equal to 3. To solve it, x squared minus 2x minus 3 is equal to 0. So this is factoring product and sum, x minus 3 times x plus 1. So x is equal to 3, x is equal to negative 1. So let's check them. If x is equal to 3, I have 3 minus 2, which is a 1, and then a 3 there, so that one works okay. X is equal to negative 1. Well, negative 1 minus 2 is a negative 3. I can't have a negative value, so I throw this one out. So x is equal to 3 is my solution. Okay. Next one. Log x minus 1 plus log 2x minus 3 is equal to log 2x squared minus 5. So there is no base there, so we make the assumption it's a base of 10. So now I can apply my rules. So if I'm adding here, that means I'm going to be multiplying. So I have log of x minus 1 times 2x minus 3 is equal to 2x squared minus 5. Log of, sorry. 2x squared minus 5. So now I can drop my logs. So I have x minus 1 times 2x minus 3 is equal to 2x squared minus 5. I do my solving. 2x squared minus 2x minus 3x is a minus 5x. Negative 1 times negative 3 is a positive 3 equals 2x squared minus 5. Okay, so if I'm going to bring this over, I'll subtract 2x squared and add 5. So I'm left with, those will cancel, so I'm left with negative 5x plus 8 is equal to 0. So x is equal to negative 8, or negative 5x is equal to negative 8. Divide by negative 5, so x is equal to 8 over 5. And if you check them, you're going to have a positive value in each one of these, so they work. So that is your solution. Okay, next one. Log base 4 of x plus 1 minus log base 4 of 2x minus 3 equals log base 4 of 8. I've got a subtract in here, so that means that is the quotient rule. So this becomes log base 4 of x plus 1 divided by 2x minus 3 equals log base 4 of 8. So now I have a log base something equals a log base something, so I can drop the logs and just solve. So I have x plus 1 over 2x minus 3 is equal to 8. So in order to solve, I'm going to cross multiply. So x plus 1 is equal to 8 times 2x minus 3. So that's 16x minus 24. So if I bring everything over, I subtract x, subtract 1. 0 is equal to 15x minus 25. I can GCF a 5 from there, so that'll leave me with 3x minus 5. So 5 equals 0, I throw out. So 0 is equal to 3x minus 5. If I solve, that's 5 is equal to 3x. Divide by 3. 5/3 is equal to x. And if you check 5/3 plus 1, that gives me a positive value. 2 times 5/3 minus 3, so 2 times 5 is 10. So I'd have 10/3 minus 9/3, so that's okay. It gives me a positive, so my answer is 5/3. One thing you can do also, if you don't like working with the divide, if you don't like working with the quotient, what I could have done here is I could have moved this over to the other side. I could have moved that part over. So I could have said log base 4 of x plus 1 is equal to log base 4 of 8. And if it's a subtract log base 4, then that means I would add log base 4 of 2x minus 3. So then this would be log base 4 of x plus 1 is equal to log base 4 of 8 times 2x minus 3. I would end up with the same answer because if you look here, my x, when I drop this out, I have x plus 1 is equal to 8 times 2x minus 3, which is exactly what I have right here. Okay, so either way you can do it. If you don't like working with the divide, then move it over. Okay, log base 9 of x is equal to log base 9 of x minus 1 plus 1/2. Well, 1/2 isn't in log form, so that means I have to change it into log form. So what they're saying is, what log base 9 of what is going to give you 1/2. So this is the same as saying 9 to the 1/2 is equal to x. Well, 9 to the 1 to the power of 1/2 is the same as saying square root of 9, which is 3. So this can be rewritten then as 1/2 is the same as saying log base 9 of 3. So now I have, because I had to change that so that it's a log, that's how I would do it. Because remember, the value that is here is what is the value, well, that would be the exponent value. So this would rewrite as log base 9 of x is equal to log base 9 of x minus 1 plus log base 9 of 3. So now simplifying first, log base 9 of x is equal to log base 9 of x minus 1 times 3. So I drop my logs. X is equal to 3x, or x minus 1 times 3 is 3x minus 3. 0 is equal to, so if I subtract my x, 2x minus 3, so 3 is equal to 2x, divide by 2, 3/2 is equal to x. And if you substitute in here, 3/2 is okay in there. In here, 3/2, so that's the same as 1.5 minus 1. So that's a positive value, so that is your solution. Okay. Oh, I seem to be missing a page. Did I? I'm just going to check in your notes book and see if I missed that page in there. Nope, didn't miss the page, just didn't move down the page. Okay. So what if you have exponential and you need to solve it? Because I can't solve this. I can't go 5 to the power of x is equal to 9 to the power of x minus 2 and then drop my bases because my bases aren't the same, and there's nothing I can do to my 5 to make it any type of exponential power to get it to equal a 9 or the 9 to equal a 5. What I'm saying there is it's not like this would have been 3 to the power of x is equal to 9 to the power of x minus 2, because then I can change these bases so they're the same. This would be 3 to the x is equal to 3 squared times x minus 2. That's not my case there. So because of that, what I need to do is I have to log both sides. So 5x is equal to 9x minus 2. I can log it, which means I would just have log of 5x is equal, or 5 to the power of x is equal to log of 9x minus 2. Now I have to apply my log rules. If there's an exponent here, that means that this becomes x times log of 5, and this becomes x minus 2 times log of 9. So what I want to do then is expand where I can. This side, nothing I can do. This side, I'm going to multiply that log of 9 through, I'm going to distribute it. So x times log of 9 is x log of 9. So I'm multiplying my negative 2 times log of 9, so negative 2 log of 9. So the next thing I want to do is I want to get my variables together. So this x log of 9, I'm going to bring it over to the other side. So I'm, in essence, subtracting negative x log of 9. So that'll cancel here. And on this side, I will have x log 5 minus x log 9 equals negative 2 log 9. So now I can GCF an x out of both of these. I'll have x times log of 5 minus log 9 equals negative 2 log 9. So I want my variable by itself, so that means I'm going to have to divide this side by log of 5, log 9, minus log 9, so I divide this side by log of 5 minus log of 9. So what you're left with then is x is equal to negative 2 log 9 over log 5 minus log 9. Now at this point here, because they are all base 10 logs, I can put them into my calculator and solve it. So that's all you do. In your calculator, go negative 2 log 9 divided by bracket. Okay? So this is in your calculator. You wouldn't put the x is equal to, but you'll put negative 2 times log 9 divided by bracket log 5 minus log 9. Hit your enter button and you'll find x is equal to, I believe it worked out to 7.48. So to give you a decimal value for your answer. Okay, so let's try a second one here. 6 to the power of 3x plus 1 is equal to 8 to the power of x plus 3. So same thing, I don't have bases that I can change like that 3x equals 9, so I have to log both sides. So this becomes log of 6 to 3x plus 1 equals log 8 of x plus 3. Use my power rules. This is 3x plus 1 times log of 6 equals x plus 3 times log of 8. So now I need to multiply and distribute. So 3x times log 6 is 3x log 6 plus 1 times log 6 is log 6. Let's do the same thing on the other side. X times log 8 is x log 8 plus 3 times log 8 is 3 log 8. Okay, so then I want to do the same thing as I did in the other one. I want to bring my variables to one side, and if I need to bring the other stuff that doesn't have a variable, in this first example here we didn't need to bring anything else over. In this example we do. So I'm going to move my x over, so minus my log, my x log 8 from both sides. And I'm going to move this log 6 to both sides. So this will cancel with that, this will cancel with that. So what I'm left with then is 3x log of 6 minus x log 8, and that's going to equal 3 log 8 minus log 6. So from here then, I'm just going to put a line through so I'm not crashing. I can GCF an x from both of these. So I'm left with 3 log 6 minus log 8 equals 3. Oh, did I write that? 3 log 8 minus log 6. Okay. 3 log 8 minus log 6. Okay. So 3 log 6 minus log 8 is equal to 3 log 8 minus log 6. So what I can do then, I need my x by itself. So that means I'm going to divide through here by, get rid of this, 3 log 6 minus log 8. That means I have to divide it on the other side. So I'm going to put brackets around here. 3 log 6 minus log 8. Now you might think, oh hey, these are opposites of each other. They're conjugates or whatever, that I can cancel them because it's 3 log 6, 3 log 8, but they're not. You can't cancel these out. So what that means is in your calculator you're going to have x is equal to 3 log 8 minus log 6. You're going to divide that by 3 log 6 minus log 8. Because these are all in bases of 10s, you can substitute that into your calculator. And when you're putting them in the calculator, I should have mentioned that in this one too, put brackets around these values in the logs. And that will make sure your answer gets entered in there correctly. So this one, x is equal to 1.35. Okay, I'm going to end there. I'm not going to worry about the problem-solving questions because on your exam, they don't spend a lot of the question time that you're doing the problem solving. It's more just on these things and on the graphic. If you want to know how to do some of these problem solvings, then just come find me and I'll go over the examples with you.